Hey guys, today we're going to go over the 5 classifications of reactions. So we've already gone through what a chemical equation is, how to balance it, and now we're going to say what type of reaction is it. So the first one we're going to start with is called a synthesis reaction. And you can call it a synthesis reaction, or it's also known as a combination reaction. So this is when multiple reactants, so you have multiple things to start with, they combined and they form one product in the end. So it's going to follow a general formula of A plus B, or it could be plus C plus D plus E, but generally a lot of times it's two things. They come together and they make one product at the end. So notice how there's no plus signs at the end, meaning it's only one species or one type of chemical. So here's an example of it. So if I have iron and chlorine, elemental, and they react to make iron chloride. So here it is, the animation. See how I have iron by itself, chlorine by itself, and they are going to combine to make only one type of product. So there are two different formula units, or two different separate things here, but only because of the two of the coefficient. It's one type of product at the end. So it doesn't matter how many of those you have. The coefficient doesn't matter, just the type of product. I only have FeCl3 at the end, nothing else. So see how there's no plus signs at the end. The next type is a decomposition reaction, and that's just like what it sounds like. Decomposition is when things break down. So this is when one reactant breaks apart into multiple products. So here's the general form. See how I have one thing to start with, and it's breaking down into two different things here. It could break down into 3 things or 4 things, but the main thing is you start with one thing. A decomposition reaction is the exact opposite of a synthesis reaction. So the first one we learned about versus this are complete opposites. So here's an example. You have seen this before if you watched the PowerPoint for 11.1. So here is potassium dichromate. Notice how we have just one type of reactant at the beginning, and then that is actually going to break apart into 3 different things. We've got potassium oxide, chromium 2 oxide, and elemental oxygen. So we have 3 types of products here. The next type of reaction is a combustion reaction, and you've probably heard the word combustion. Ba-boom, right? When things explode. So this is when any substance reacts with oxygen to form oxides as its products. So you've seen this whenever you light a fire. If you've ever had a match going or a candle going, or maybe the fire pit, you know that it takes oxygen to get the fire going. Well, that's a combustion reaction. You need oxygen to supply it. If you've ever tried to put a candle out after a dinner or something, you can use a thing, it's called a snuffer, which actually just sits on top of the candle and blocks out the oxygen, and that's how you can turn the fire off without blowing any wax anywhere. So there is no general form for this, but the key thing is that oxygen, elemental oxygen, is a reactant. So you have to start with O2 at the beginning, and then every single product has oxygen in it. So in the combustion reaction, every element in the reactants combines with oxygen to make oxides as its product. So if you look here, we've got iron reacting with oxygen. So iron reacts with oxygen, and notice it's iron 3 oxide in the end. So our only reactant that's not oxygen is iron, reacts with oxygen. Everything in the product is with an oxygen. So here that is iron reacting with oxygen, rearranges. Everything in the product is bound to at least one oxygen. This reaction also happens to be a synthesis reaction. Do you know why it's a synthesis reaction? So if you don't know, go back to your notes. So freeze the video, go see what a synthesis reaction is and see why this fits it. Okay, this is a synthesis reaction because in the end, I only have one type of product. Notice how both of these things are Fe2O3. That's the only thing you end with, so that's a synthesis reaction. Synthesis means you've made one thing at the end, and that's it. Another thing you need to know about combustion reactions is whenever you combust a hydrocarbon, which is a compound that's just hydrogen and carbon, that's why it's a hydrocarbon, you're always going to make carbon dioxide and water vapor. So for example, if we have methane, CH4, and oxygen, so methane reacts with oxygen to make carbon dioxide and water. Notice that the carbon is bound to oxygen at the end, as well as the hydrogen is bound to oxygen at the end. Everything at the end has to be an oxide. Also, the biggest part is that O2 is one of your reactants. So if O2 is on the left-hand side, that way, on your chemical formula, then you know it's a combustion reaction. So here's the animation for that. You're always going to have some sort of energy released during a combustion reaction, whether you hear it as a noise, or maybe you see it as a light, or it's giving off heat. So that would always happen. All right, our fourth type of reaction is a single replacement reaction. So this is when an elemental reactant replaces a similar element in a reacting compound. So the replaced element is elemental as a product. Whoa, that's a lot of words. All right, so to explain replacement reactions, I want you to imagine your elements as kind of being people for a second. And instead of going through a reaction, they're going to a party. I know this sounds weird, but just give it a whirl. So let me show you the general form for a single replacement reaction. You've got A by itself combining with BC as a compound. At the end, A is no longer by itself. It's with C, but B is now by itself. Remember how I said personalities and think of the reaction as being like a party? The reactants are who arrives at the party. The products are how they leave. A came to the party stag. B and C came to the party as a couple. Uh-oh. Look at this. A and C, they're leaving together. B is now elemental. Someone's always single at the beginning and someone's always single, but it's a different thing at the end. Also, like will replace like. So a metal will replace a metal, or a non-metal will replace a non-metal. So let's go through this reaction. Aluminum reacts with iron chlorides, well this is iron 3 chloride, to make aluminum chloride and iron elemental. Notice I started with aluminum elemental, not bound to any other element, and then I have a compound it's reacting with. At the end, aluminum is now with chlorine. Notice my aluminum replaced my iron, so those are both metals, and then iron is now elemental. So here's the animation. So aluminum came to the party or the reaction by itself, and then the reaction goes like this, switch places. So the single thing replaced something else. To determine if this is going to happen, you have to be more reactive than what you're replacing. So what I mean by that is you're going to use the activity series of metals, and then I'll tell you in a second how we predict non-metals, how they're going to react. So up here would be the most reactive metals. Down here would be the least reactive metals. If your element is higher up, then it can replace because it's more reactive. It can kick out the other element. So let's make a prediction. Will gold be able to kick out aluminum in aluminum chloride? All right, let's pull up that activity series again. First, let's find gold, AU. That's at the bottom. It is the least, so the most non-reactive or the least reactive of our metals in our series. Aluminum is more reactive. So you can think of it as like aluminum's cooler to be with at the party, of the reaction party. So chlorine isn't going to get rid of aluminum because aluminum's more reactive. So gold doesn't have enough energy to kick out aluminum. So because gold is below aluminum on the activity series, this reaction will not occur. And you can write NR, or you can cross out the arrow here. A lot of people cross it off and put NR, which is kind of redundant, but it's better to cover all bases. Let's do another one. Sodium reacts with aluminum chloride. So sodium's the metal and aluminum is the metal. So will sodium be able to kick out aluminum? Is sodium more reactive? So we have to find them. Here's sodium, here's aluminum. Since sodium is further up, then it means it's more reactive. So if it's more reactive, it's able to boom, 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 kick out that aluminum. So sodium will replace aluminum because it's above it on the activity series, meaning it's more reactive. So how about for nonmetals? Well, for the activity series for nonmetals, the only one we really classify is halogens because they get a little weird other than the halogens. And it's right there on the periodic table for you. So here's a periodic table, and boom, there are your halogens listed right there in group 17. So will this reaction occur? Well, the halogens are listed for you in order up to the top. Fluorine is the most reactive of the halogens. So when you look at what's similar about these, our nonmetals are fluorine and chlorine. So will chlorine be able to replace the most reactive element of the halogens, fluorine? No. This isn't going to happen because fluorine is further up. You would need something above it, and there isn't anything above it. So since fluorine and chlorine are right there, chlorine is not able to replace, so no reaction will happen. Our last reaction to talk about is a double replacement reaction. Now this is really similar to the single replacement reaction, except for now everything's doubled up. So this is when two compounds react and the elements switch bonding partners. So here's the general equation. AB plus CD yields AD plus CB. You're still going to have a metal with a nonmetal and a metal with a nonmetal. So you can either think of it as the metals replacing or the nonmetals replacing. So here's an example. We've got silver nitrate reacting with potassium chloride. So in this, my nitrate is kind of acting like my nonmetal because my silver has the positive charge. So your cations are switching places here. So let's show that animation. So here's the reaction party, boom. So notice, I'll do that again. Our metals are silver and potassium, and that's what's going to do the switching. The other thing to notice, what makes this different from a single replacement is in a double replacement, everything's always partnered up. So there's nothing that's elemental at the beginning or the end. Everything's always in a compound. So that's why it's double replacement, because everything's doubled or with something else. Everything's in a couple, right? At the beginning, silver was with nitrate. At the end, silver's with chlorine. At the beginning, potassium was with chlorine, and then potassium is with nitrate. So nothing's ever elemental at the beginning or the end. And that's your double replacement reaction. So those are your 5 chemical reactions. You're going to have some practice identifying them in some activities coming up, but be sure you talk to a teacher if you have any questions right now. Okay, good luck.